All right, pop quiz. What do you think runs the world today? Phones, computers, social media? Nope. It all boils down to just two numbers, 0 and 1. These days, our computers, phones, and tablets might look like insanely complicated machines, but deep down, they run on one ridiculously simple principle. They process information in tiny pieces called bits. So, what's a bit? A bit is the smallest piece of information a computer can understand. It's either a 0 or a 1. Think of it like a light switch. It's either on or off. That's exactly how a computer sees a bit. But bits aren't just about light switches. In an electrical circuit, if there's current, that's a 1. If there's no current, that's a 0. Even your hard drive stores bits by flipping tiny magnetic fields. So 0 and 1 might take different physical forms, but they always mean the same thing. So what do these bits do? When you put a bunch of them together, they form a complex language, kind of like how humans put sounds together to make words. A photo? A video? They're really just millions of bits in a special order. Computers take those patterns and use them to perform tasks. All the math they do, adding, subtracting, happens inside tiny circuits called logic gates. And it's all based on just two states, 0 and 1. Now imagine you have a really complex problem, like evaluating millions of possibilities all at once. A regular computer? Yeah, it would check them one by one. And you might be here until next Christmas waiting for the answer. But what if we had a computer that could check all those possibilities at the same time? That's the magic of quantum computers. To make them work, we needed something way different from the classic bit. Enter the qubit, a word you've probably heard but never really understood. Unlike bits, which can only be 0 or 1, qubits can be 0 and 1 at the same time. That's a weird quantum thing called superposition. What do you mean it can be both at the same time? I can hear you asking. Don't worry, my friends. Let me explain it with a coin flip. When you flip a coin, while it's still spinning in the air, you don't know if it's heads or tails. Both are possible, but when it lands, you get just one result, heads or tails. Quantum systems are kind of like that. While a qubit is in play, it can be both 0 and 1, like a coin spinning in the air. But the moment you measure it, just like when the coin lands, it picks one outcome, 0 or 1. And because qubits can juggle all those possibilities at once, quantum computers can crunch an insane number of calculations simultaneously. That's what gives them their mind-blowing power. Oh, and qubits have another weird quantum superpower called entanglement. But fair warning, if we go down that rabbit hole, forget YouTube. Even CERN might throw in the towel. Don't worry though, I've actually made a whole video on it, and it's just sitting on my computer waiting to go live. If you want me to bump it to the top of the coming soon list, just drop a quick "I want it" in the comments. Oh, and while we're here, if you're enjoying this, come on. Smash that like button, buddy. Of course, nothing's perfect. These gigantic, super smart machines we call quantum computers have their downsides too. Yeah, you heard me right. Gigantic. These things can take up more space than the rooms in your house. And not just any rooms. I'm talking about ultra-controlled labs where even the humidity is carefully adjusted. A tiny little shake can mess with how these computers work. Quantum computers need lasers, mirrors, massive machines, and super delicate environments. So the chance they'll show up in your daily life anytime soon? Honestly, it's slimmer than you becoming richer than Elon Musk. But here's the kicker. Some brainy folks at Harvard, yeah, those genius wizards, managed to squeeze this complex system into a single chip. This breakthrough means quantum computers might one day be way smaller, portable, and actually everywhere. In this chapter, we explored the journey from classic bits to qubits, the building blocks of the quantum world. Now, let's dive into Harvard's chip technology. But first, time to hit that subscribe button. I'm waiting for you. Odds are most of you already did, so let's keep going. Remember in the last episode, we talked about quantum computers being these huge, room-sized machines running in super special labs? So, how exactly does such a delicate computer even work? Well, the truth is, these computers use particles of light. Lenses, mirrors, optical cables, light routers. All of it together takes up a big table, sometimes even a whole room. That's why what our buddies at Harvard did is such a big deal. This team managed to fit an entire quantum optics lab into a chip just a few centimeters across, meaning quantum tech can now rely on chip technology instead of these complicated optical setups. How did they pull it off? Harvard developed an integrated photonic chip. In simple terms, they can guide light particles, photons, through the chip. Just like electricity flows through circuits, light paths are carefully designed on this chip. And it's not just about making things physically smaller. They use advanced math like graph theory to figure out how photons interact and which paths they take. The result? A massive lab now fits in your pocket. This is a game changer, not just for engineering, but for making quantum tech mainstream. Maybe soon you won't ask Uncle Google for help with your homework, but Quantum Uncle instead. But wait, there's more. I haven't even told you what's really inside this chip. How is the light guided? How do photons affect each other? Because it's pretty technical, I split the video in two. If you're curious what's packed inside this chip, click right here to watch part 2. See you there, quantum fans. Smash that like button.